Element 5, Electrical Safety. 1. Identify the possible effects of electricity on the body. Electric shock. Severe electric shock can cause involuntary muscle grip, heart fibrillation, respiratory failure and cardiac arrest. Burns. Burns can also result from an electric shock, at the point of contact and at the point that the current flows out of the body. There may also be internal burns along the current path. Fire and explosion. Arcing. Secondary effects. Outline 4 factors that may affect the severity of injury from contact with electricity. Several factors influence the severity of injury associated with receiving an electric shock. Voltage. As Ohm's law shows, there is a simple relationship between voltage and current. The higher the voltage, the greater the current. Duration. The length of time that a person is exposed to the flow of electricity is critical. For example, a current flow of 60 mA for 30 milliseconds, 30,000ths of a second, is unlikely to cause a severe injury, whereas the same current flow over a period of 2 seconds can induce VF and prove fatal. Frequency of the AC current. Current path. The route that the electricity takes as it flows through the body is also critical. If it runs through the chest, it is likely to affect the heart. Resistance. As Ohm's law shows, there is a simple inverse relationship between current and resistance. The higher the resistance, the lower the current. Most of the body's resistance to the passage of electricity is because of the skin. A person with dry skin has a resistance of about 100,000 ohms. But if their skin is wet or damaged, this reduces dramatically to 1000 ohms. Any clothing that the person is wearing will also affect their resistance to the passage of electricity. Contact surface area. The more skin that is in contact with the live surface, the lower the resistance and the more severe the injury. Environment. Any environmental factors that reduce resistance will cause an increase in current flow and therefore increase the severity of the shock, for example wet surfaces, humid air, metal surfaces, etc. 3. In relation to the use of electrical cables and plugs in the workplace, identify 4 examples of faults and bad practices that could contribute to electrical accidents. Using unsuitable equipment, for example the use of non-intrinsically safe equipment in a flammable atmosphere. Using equipment in wet, damp or humid conditions. Misuse, for example sticking wires directly into a socket rather than using a plug. Physical abuse, for example pulling the plug out by tugging at the flex, carrying the tool by the flex, allowing the flex to be pinched, trapped or crushed, driving over the flex, etc. Repairs carried out by unauthorized personnel or carried out badly, for example split flex taped up with insulating tape. Continued use of faulty, defective equipment. Chemical damage to the flex, for example by corrosive wet cement. Lack of routine inspection, testing or maintenance. 4. Explain how earthing can reduce the risk of receiving an electric shock. Earthing is a way of protecting equipment so that in the event of an electrical fault, current flows safely to earth rather than flowing through a person who might be touching the equipment. The earth wire of an item of electrical equipment is usually connected to the outer metal casing or chassis of the equipment. If a fault develops and the casing or chassis becomes live, then a current will flow down this earth wire. Electricity always takes the path of least resistance, and since the earth wire will have very low resistance, the majority of fault current will flow safely to earth through the wire. Any person touching the casing will receive minor shock. 5. Outline the emergency actions to take if a person suffers a severe electric shock. The action of discovering a person having suffered an electric shock should be to make others aware of the situation and, at the same time or immediately afterwards, to turn off the supply. If this is not possible, and the victim is still in contact with, or in close proximity to, the live part, then he or she should be pushed clear using a non-conductive implement, such as a broom. First aid should then be administered, which, depending on the condition of the person, may include cardiopulmonary resuscitation. If successful, an airway should be maintained by placing the victim in the recovery position and breathing should be monitored until medical help arrives. 6. Outline the practical measures to reduce the risk of injury from electricity when using a portable electrical appliance on a construction site. Section Consider the use of battery-powered equipment. Consider the use of reduced and low voltage, 110 V, equipment center tapped to earth. Provide increased protection through the use of an RCD. Locate cables carefully, away from hazards, for example vehicles which may drive over them. Consider the use of double insulated equipment. Carry out pre-use checks of the equipment for signs of damage. Train operators in safe use of the equipment. Avoid using in wet conditions, unless the equipment and supply cables are suitable for this. Implement a program of routine visual inspection and thorough testing of electrical equipment and cables. 7. In relation to electrical safety, explain the meaning of the following terms. Isolation. 2. It refers to shutting of the electrical supply to an item of equipment or part of an item of equipment or part of an electrical system and preventing inadvertent reconnection in order, for instance, to carry out maintenance work. 2. Earthing. 2. This means whereby electrical equipment and conductive items are connected to earth by a cable or metal pipework such that the route to earth provides the path of least resistance to a current flowing under fault conditions. 3. Reduced low voltage. 2. Commonly used on construction sites, involves the reduction of local supply voltage by a transformer to a lower, safer voltage, typically 110 or 55 volts. 4. Overcurrent protection. 2. A method of preventing the flow of excess current by cutting the supply under fault conditions by means of a fuse or circuit breaker. 8. Identify the electrical hazards that could be discovered by a visual inspection. 8. Worn cable. Max current capacity exceeded. Overheating. Defective equipment. Exposed electric cable. Misuse of electrical equipment. Failure to follow safety instruction. Incorrect fuse rating. Poor connections. Bad circuit connections.